for you to do exercise 9B, you have to know this. The mean of sample mean. Okay, sample mean, we write it as X bar N is equal to population mean. Your population is X. Population mean. So we write it as like that. Okay, that is the first relationship. The standard deviation of sample mean. Your variable is the sample mean, okay? Is equal to the population standard deviation divided by square root of the sample size. Why divide? Because as the sample size become bigger, okay, I just write like that. As the sample size become bigger, that means that sample give a better representation of the population. So the sample mean of each samples will be very close to each other. That's why the standard deviation of the sample mean will be equal to the standard deviation of the population divided by square root of n. So throughout this exercise, we are going to use this particular property. Are you okay? So everyone, can you please go to exercise 9B? Please do question 1A. So before you do question 1A, may I know what do you mean by X bar 4? Okay, how do you define it? How do you define this? Can you please tell me? Anyone? You can type. Hello? No one? So if I say X bar 4, that means this is the mean of samples, the mean of random sample, the mean of random samples, whereby for the mean of random sample for of sample size 4. Okay, the mean of random sample of sample size 4, which means 4 result sample size 4, which means for result of X. So I mean each sample, you draw 4 results from X. And your sample must be a random sample. And what do you mean by random sample? Okay, what do you mean by random sample? Can someone tell me? When you say random, that means there's no specific order. Random sample, that means every one in the population has an equal chance to be selected as part of a sample. That is called a random sample. Your sample must be random. Everyone have an equal chance to be selected as part of a sample. That's why yesterday when we did that, correct? That's why you spin once. When you spin the second time, you may get 1 also. If you talk about pick something from a box, that means you pick and replacement. You put it back again. Are you clear?
Yeah.
Yeah. So you have to be very careful. Okay. So now, can everyone do part A? So every time when you have X bar something, you must try to explain. Okay. That you will see this in question 2. Okay. Can you please do? So my X, this is the population. Is your X. The mean for X of the population is 20. And the standard deviation of the population is 6. So this is my sample mean of sample size 4. That means I take an exotic samples, number of samples, and each samples I find the mean. That means this sample mean distribution, the mean for this sample mean distribution will have the mean equal to the population mean. So the mean will be 20 also. And the standard deviation for this sample mean distribution will be equal to the standard deviation of the population divided by square root of n. So this will be 6 divided by square root of 4, which is 3. Okay. Now I want to extend from here. Can everyone try to sketch the distribution of the population and the distribution of the sample means of sample size 4 on the same axis? Please. That means this represent X, also this represent X bar 4. Both have the same mean. Okay, if you refresh back your SAT 5, then you will know what to do. Okay, I give you 5 minutes to do that. Okay, 20. Yes, you are right. You are right. Not 50. What am I talking about? Okay, 20. Okay. So here will be 26, 32, 38. Here will be 14, 8, and 2. Okay, then we make a comparison between the standard deviation. So we know that one of the standard deviation is double the other one. Okay, so what I need to do is, if I plot X with blue, then X definitely will be lower. Correct? And I plot black for X bar 4, that means X bar 4, the height will be double. So that will be the higher point of X bar 4. So now, for any normal distribution, we know that they will fade away at 3 standard deviation away from the mean because of this true fact. So that means the chances of it to get out of the 3 standard deviation away from the mean is very unlikely. So that's why it will touch. And the next point we have to take notes of is the inflection point. So it will be around here. We get all these points done, then only we can draw the graph. Convex, concave down, then convex. Then you put the arrow at the two ends. Every time when I mark through your S85, right, the way you draw the graph, right, you are not close enough to the horizontal axis. At the 3 standard deviation, it almost touches, but it doesn't. It approaches 0, but it's not 0. Okay, so this is your X. So now I start to do so I divide this into half. Got it? So my 3 standard deviation for the black, that is the X bar, 4 will be 1, 2, 3. So it fade away here. See or not? And the inflection point is roughly here. 2/3 down. So now you draw convex, concave, then convex. Then your graph will be very nice. This is your X bar form. Will this happen again in your S86? The answer is a yes. So in this case, I can even ask question like during the exam. I say, okay, which one will have a higher probability? X bar 4 greater than 26 or X greater than 26? The answer definitely is this one, because you have a wider spread. You see, when we talk about the area, 26 is here. This is the one. For the blue one, it is this whole area from here onward. See or not? But if you talk about less than, then it's the other way around. Are you clear? Okay. Any further question? Any further question on this? So the X bar 21, you know what to do, huh? Hello? Whatever I discuss here is not part of the answer for this question, okay? Okay, so can everyone turn to question 2? Okay, take out your calculator. Every time you want to find the mean and the standard deviation given a probability distribution table, straight away use a calculator, please. Okay, turn to page 262, question 2. Whatever given in the table there is the population. Huh? So you see the population only got 3. I can have a, I can draw a samples of sample size 7 because I can repeatedly draw the same number over and over again. That is called a random is selection with replacement, okay? Okay, Siti, can I have the mean?
5.
5. Can I have the standard deviation?
42/3.
Okay, how do you get sub 42/3?
I use the x square times
Okay, you are using this formula, is it? Are you using this formula?
Yes, miss.
Yes. If you are using your calculator, what does your calculator give you the answer? Siti?
2.16.
4.16.
2, miss.
So where do you need to key in into your calculator, Siti?
Miss, it's 2.16.
Or 2.16. Okay. So where do you key this into your calculator?
The second quit.
Second?
Quit.
Second?
Or use the state, miss.
Yeah, you use the stack. Then after that?
To calculate the.
So you first of all, what must you do first?
Edit.
Edit. Then you key in the data. Right? After you key in the data, then what you do? You go back to your second mode first, quick first. Then after that, you put stack again. Then you select calculate.
And then one variance.
One var stack. Yes. Okay. So all these technique, later on when you write your folio, you also can put in. Are you clear? This is called technology. How you use your graphic calculator to help you to calculate certain things. Are you clear? So this will be your technology part. Okay, so now we are done with part A. Part B. So how are we going to explain part B? Explain what the random variable x bar 7 represent. X bar 7 represent the mean of what? Noor Amira. The mean of what?
The mean of random sample of sample size 7.
Yeah, the mean of random sample of sample size 7, which means that 7 from X are selected. Okay, sample size 7 means 7 from X are selected. Random 7 of X are selected. Okay? So now, find the mean and the standard deviation of this one. Okay, so now find the mean of, so you have always, when you do this kind of question, correct, always write down like that, is equal to the population mean, is equal to 5. Don't straight away write equal to 5. Yeah. And the standard deviation of the sample mean distribution of 7 sample size 7 is equal to standard deviation of the population divided by square root of n. Okay, so this is 2.16 divided by square root of 7, and you get from the answer. Okay. Got it? Okay, can you please go to question 3? There are something I want to explain from question 3. Please go to question 3. As you read, you must jot down the information. Okay. Every time when I read a question, I will write down as much as I can. So for part A, correct? Whatever given in part A is the value of a sample. This is a sample. So when you talk about a sample, when you count the sample mean, so this is a sample mean. One particular sample. So that particular sample, what is the mean? Can you tell me? Hello? Can you tell me what is the answer? No one? I pick. Kevin? What is the mean for this particular sample? 2.975. Is it correct, Kevin? Okay, now I want to ask you further. They say, what is the corresponding observation value of the random variable X? So a sample mean. This particular sample has a sample mean of 2.97. So now I want to ask you, what is the standard deviation for this sample? Can you tell me? Kevin, can you tell me? No one? What? Kevin asked what? Okay. Azif, do you know what I want?
Teacher, I said wait.
You say wait. Okay. Azif, do you know what I want from this question? What is the standard deviation for this sample? Yeah, I want standard deviation. So can you give me the answer? Can you give me the answer? Azif? Oh, wait. Oh, this one also wait. Okay. So everyone is waiting. Hafiz? Once you see what number you give me, then I will know your understanding. Okay. Kavan, give me this value, 0.03. Hafiz also give me this. You take this. Divide by square root of 10. Do you know you are doing the wrong thing? I'm not asking that. I'm asking what is the standard deviation for this sample? Yes, thanks. No. Nick. Thanks. Nick, give me the right answer. I'm talking about sample standard deviation, which is you have to key into your calculator one bar stack, you look for this. This is called sample standard deviation. What is the standard deviation for this sample? I'm not talking about the standard deviation of the sample mean. You cannot use this formula. You key the data into the edit. Then after that, you quick, you go one var stack, then you look for this. Are you clear? So it's 0.139 mm. So be very careful whether the question is asking the standard deviation for this, the sample, a particular sample, or asking the standard deviation of the sample mean distribution. Do you get me? The standard deviation of an individual sample should be almost the same as the population standard deviation. If your random sample are selected randomly, and you see the mean of a particular sample is also quite near the population standard deviation. Mean. Some will be a bit more, some will be a bit less. Do you get what I mean? Student? So have to be very careful. Got it? Then part B. Part B is the one that you are supposed to use this formula because they say, what is the mean and the standard deviation of X bar 10? You see, I purposely write for part A, correct? I purposely write this as a sample mean. You see, I use the word a. That means the mean of a particular sample. So this is a standard deviation of a particular sample. Got it? Okay, so the answer for part B, you should know what to do. Yeah. Okay, so all the important things I pointed out to you. So part B, the mean. So now for part B, the mean of the sample mean distribution is equal to the population mean. So equal to 3. The standard deviation of the sample mean distribution, not a particular sample, is equal to the standard deviation of the population divided by square root of n. So this will be 0.12 divided by square root of 10. That is where 0.038. Clear? Okay. So the rest of the question, please do it by yourself before Monday. Monday, I'm going to explain exercise for a 9C. There are a lot of things to talk about, 9C. Then we will do 1 or 2 questions from your, times I have uploaded a few questions. Got it? And one more thing I want to encourage you to, can you please, okay, now you spend some time, read yesterday, second bullet, can you understand? I will explain. Okay, if n observations are chosen without replacement from a finite population, then n must also be small compared to the size of the population. This is to ensure that the observations are approximately independent. Do you know the meaning of? Okay, so bullet 2. bullet 2, the keyword is without replacement. You understand the meaning of without replacement? So n must be small. So that it is approximately when I use the word approximately independent, what does that mean? When I use this word independent, what does that mean? Can anyone give me the meaning of independent? Hello, you have to learn. Okay, does not affect the others. So what does that mean? We know that our sample must be a random sample, correct? A random sample, that means everyone must have an equal chance to be selected. So the approximately independent here means every element will have an equal chance to be selected. Are you clear? So like, for example, okay, in my population, I got 100. So the first one that I select, the probability of selecting is 1 out of 100, correct? So if I don't do a replacement, so I left with 99 inside here. So the second one that I select, so what is the probability? Will be 1 over 99. So you look at 1 over 100 and 1 over 99 is approximately hello? So that is called approximately. So if you don't put a replacement, then you make sure the sample size must be small. So that the probability for the first selection and the probability for the second selection will be the same. Approximately. That's why they use this word approximately. Okay? So someone requested me to talk about the fourth bullet. The fourth bullet, the result regarding the normality of the sample mean also apply to the sum. Still remember your exercise 9A? 9A, do you know what is the meaning of this? I'm talking about the shape of the graph also. If the sample size is large enough, if the original population is normally distributed, the sum will also be normally distributed, regardless of the sample size. But we know that this distribution, the mean will be equal to what? Hello? From your exercise 9A, you tell me what is the mean? Hao Xuan?
Where?
What is the mean? How to find the mean? N times by the mean of the population, correct? And the standard deviation for this, the sum of n elements will be equal to square root of n times by the standard deviation of the population, correct? This is from your exercise 9A. We learned from exercise 9A. So the bullet 4 here is to tell you that same thing. If the population is normally distributed, the sum of the sample of size n will also be normally distributed with the mean of this and the standard deviation of this. If the population is not normally distributed, okay, then your n must be more than 30 by times of root in order for it to become normally distributed. Or as the number of n increases, then the distribution of Sn will become approach normal. You get me? Understand? So this you have to refresh back to your 9A. So later I will teach you how to do 9C question from both perspectives, depend on what the question wants. Are you clear? Okay, everyone. So you have to know every symbol that we use. You have to know exactly what is it and how is it related. You get what I mean? Okay, any further question? So please complete your exercise 9B. You should be able to answer most of the question already. Okay, then Monday we will talk about 9C and Tuesday. A lot of things to talk about in 9C before I go to confidence interval. Okay? Shall we?